So, they're asking part A. Excuse me. Did you guys make it through that homework okay?
Nope.
Last two.
They were horrible. They were disgusting.
Were they tough? What was it? I can't remember now.
Last two.
It was
0.3.
what was it? It was 18 and
17, 18,
17, 18, 19. Those three were
What
stupid.
was it? Oh, the cans and
The can
the
was 19. The cube was what? 18 or
cube and the fence.
17? Yeah.
Yeah, so come see me if you're having trouble, or Roberto, or get the help you need. Even come up after class for 5 minutes to do what I can. I have upstairs 12 to 1, today, Monday, Tuesday, Wednesday. Come get those down there for sure on the test. No secrets with me. No, there's one of them's on the practice exam, another one's on the real exam. I don't remember which ones. But yeah, for sure, you'll be tested on one of those. Right? So make sure you can do those. Those are really, it's because you do that in calculus. That's why I'm being so for sure on that. That's something for sure you need to know for calculus. So I really want to, that's always my goal is getting you calculus ready. So yeah, make sure you master that. You can do it. Just look over the YouTube's practice. Come see me if it's confusing. Be glad to help. Roberto can do that. When is our test, by the way?
In October.
It's next month. Oh. Yeah, it's, week after next, huh? Yeah, today's the 18th. So next Thursday is our practice exam. And then the week after next, on Tuesday the 3rd, is our exam. Yeah. All right, here we go. F of x is less than 0. Less than 0. Now, f of x is y. Remember, function values are y values. G of x, h of x, all those are y values. It's by common agreement in the math science world. So they're really saying y less than 0, meaning y negative. Where are the y values negative? Here and here. Wouldn't you agree? Those two parts of the graph, the y values are negative. And this goes forever. This part does. And this part just goes from what? 0 to 2 on the x-axis. See how they say interval. Remember what interval always means? X with x. X on the left with x on the right, huh? So there's two intervals. If this is the x-axis, it goes from negative infinity up to negative 3, comma, 0 to 2. Does that make sense there? Oh, I did that. So I just looked at the graph. And I said, hey, what sections are negative? Or are the y values below? From negative infinity up to negative 3, from 0 to 2. Interval always means x values, left, right. And it's always parentheses y. If they had less than or equal to, then they would want me to include like the 0 right on the money and the 2 right on the money. Because right at 0, it's at 0, and at 2, it's at 0. But they didn't want equals. They don't want to know where the height is equal to 0. They just want to know where the height is below 0. So it's below 0, not right on 0 or right on 2, but close to 0, close to 2. Does that make sense? So basically, if they have an equal bar here, then you'll have bars here. And at the negative 3 as well. Never on the infinity, right? Because you can never be right on infinity. So that would be the answer if they said less than or equal to. Because then you would include the points right on, right? But they said less than, no bar, so then we have no bars. So, okay, and then part B is saying, where is it greater than or equal to 0? Well, here and here. So that's from negative 3 to 0, brackets now, negative 3, because they have the bar, right? So they want the equal 0 right on the money, comma, and from 2 to infinity, huh? From 2 to infinity. Oh, bracket on that 2, bracket on that 2, 2 to infinity. Is that good? For the greater than or equal to sections, the red sections? All right. So number 2. Okay, so where is it? Where is it greater? Where is f of x or y greater than 0? Well, this section's greater than 0. From here up is greater than 0, and that's it. Those are the two sections greater than 0. You agree? So what are the intervals? This one goes forever left, so negative infinity up to negative 2. Let me move it up here. Negative infinity up to negative 2, comma. I think they want a comma in the middle. Sometimes they want I think they just want comma. On test, I don't care. Any of them are fine. And from 0, it's intervals, so it's all x values, huh? From 0 to 1. On that? Good? From 0 to 1. No bar here, so it's parentheses on everything. No bar, no bracket, right? BB, bar, bracket. They go together. So no bar here, no bracket. Okay, now part B asks the question. That's part A. Part B says, where is f of x less than, meaning y, less than or equal to 0? Well, that would be right here and all of this. Right, those are the below 0 parts. What are the intervals there? -2 to 0. Now, we'd like to put brackets because we have the equals bar, but can you really hit this dotted line here?
No, we would always skim it.
Yeah, so we really don't. We go back to parenthesis because you can never be right on that -2. It's a vertical asymptote. Everybody see that? But we do have a bracket at the 0. Everybody see that? So always parenthesis at vertical asymptote, right? Because you can never be right on a vertical asymptote. You never hit a vertical asymptote. Cyrus?
So it hits the y equals 0?
Yeah, right? Boom, right there, right?
Oh.
Solid point right there. Yeah, no vertical. There's no vertical asymptote going through that point. Yeah, so we do get a bracket at the 0 because we have the bar here. So when you have the bar, the equals, then you want to do brackets if you can. The only time you cannot is at a vertical asymptote. Or infinity, of course. So then what's this section here? This goes from 1 to infinity, huh? Bracket. Oh, we can't do a bracket at 1, can we? Because of vertical. So parenthesis 1, so they end up with parentheses as well. So no bracket at 1 and no bracket at -2 because those are verticals, vertical asymptotes. Good? So there, is that okay? Questions I can answer? Okay, so they're saying, where is the thing? They're saying f of x greater than or equal to 0. That's y greater than or equal to 0. So where is it greater than 0? Starting here, all of that. I didn't draw it so well. But all of that is greater than or equal. So that goes from what? -1 to infinity, doesn't it? And they have the equals bar, so I want to put bracket at -1 to infinity. Makes sense? Now, yeah, how do I explain this? So, in a minute, they're going to pull away the graphs, and we're going to have to do this without a picture. They're kind of warming us up, like giving us training wheels, and then in a minute they're going to pull off the wheels and say, ride the bike, no picture. So let's start helping with that. So look at that. What if they didn't give me a picture on this one? What if they gave me x plus 1, x minus 2 squared, and they just said, hey, I want to know where it's greater than or equal to 0, right? Because that's what they're basically saying. Where's the function greater than or equal to 0? How would I do that? Well, could I come up with that graph on my own without a lot of work? Yeah, I would just say, what are the zeros? -1 makes that part 0, +2 plugged in for x. Right, we're saying, what could I plug in for x? What could I plug in for x that would make the thing 0? So that means at -1 and at +2, it's going to go through 0, and those are the only places, right? Remember how we learned all that? And then what's the end behavior? Remember, because you find out in the end, does it go off to the up or down? What's the end behavior? Then you kind of trace it backwards, huh? What's the end behavior of this graph? Well, if you multiplied that out, if you took x plus 1 and x minus 2 squared, y equals, and you folded it all out, positive x cubed would be the front term, wouldn't it? Which means up, positive is up. So it's going up in the end. And then the last thing you got to be clear on is, does it bounce or pass through at these two places where it hits the x-axis? How do we determine if it bounces or passes through? It's a real important difference. Yeah, even is bounce, huh? So at the 2, it's going to bounce. So this is a bouncer, and this is a pass-through, so it's going to bounce up and pass through. And so we're able to get that graph, and then we can answer the questions pretty easily. Does that make sense? So that's what they'll make us do in a minute. We go. They're done giving us pictures. Okay, so x plus 2 squared, x minus 6 less than 0. So there's a couple ways that you could do it, whatever's easiest for you. It might be nice to just get your own little picture real quick if you want. So why don't we do that? So what would the picture look like? What would the zeros? Well, let me let you rather than me just do it. Go ahead and get a quick little picture. You know, find out the zeros and find out if it bounces or passes through, and then you need the end behavior, like what it does way off to the right, and then kind of trace it back. And then after you have that, go back and the answer is going to be those places that are less than 0, right? The places that are below, where the y values are under the x-axis. So we can get that. -2 and +6 make those 0, right? So -2, +6, the places it's going to hit the x-axis, the only two places it's going to hit the x-axis. So, okay, and the 2 has an even power, so it's a bounce, and the 1 power is a pass-through because it's odd, like that. So it's going to bounce at this one, it's going to pass through at that one. Good there so far? Now, what's the end behavior? Yeah, positive x cubed. If you multiplied all this out, positive, so it's up. So it's going up at the end, and it's going to pass through, come back up, bounce, like that. We good for a rough sketch of the thing? Now, take that picture, and what do they want? They want to know, okay, where's that function less than 0? Where are the y values less than 0? So go back and they want an interval, right? So we always want an interval, left edge, right edge. So where is it less than 0? Isn't all of this? Oh, not the -2 though. Oh yeah, gotta be a little careful, huh? It's gonna be, yeah, it's a little tricky. Yeah.
Looking at the x.
It's going to be, yeah, so the final answer is the x. They want interval. Yeah, so I'm going to go x on the left, x on the right, you know, for my intervals. Yeah, so it goes from, on the x-axis here, it goes from -infinity to -2. But we got to separate then -2 up to 6. Do you see why I've got to make those two separate intervals? And I can't just say, look, all the way from -infinity to 6, because it doesn't include the 2, right? Because we're saying less. If we said less than or equal to 0, then I would just go straight from -infinity to positive and put a bracket at 6 and be done. Does everybody make sense? If they said equals, if they said less than or equal, I would have changed, because then it would just have been everything from -infinity, including this spot, because that's equal 0. All the way up to the 6, including the 6, bracket at 6. I would have said, look, everywhere from -infinity to +6. But since they said less than 0, not equal, they don't want the equals, then they don't want the -2, because at -2 it equals 0. So I've got to do two separate intervals, not including the -2 that way, with the parentheses. That's my final answer. Is that good? On that? Questions I can answer? Good. Okay. Let's see here. So 2x cubed greater than -6x squared. Well, I think the easiest thing would just be to get a 0. Have you noticed? Look back. It's all been about 0 on the right side. See, 0's on the right side. 0's on the right side. We've always had 0 on the right side. That's the easiest thing to do, I think. So just jump that over. You know, get a 0 on the right side. And then what else do we have to do with the left side? Factor, right? See how the left sides are always factored? So let me just write these steps out. Number 1, get a 0 and factor. And then graph. So get a 0, factor, and graph. So factor that. So go ahead and factor that thing, and then make a quick little graph like we've been doing with the zeros and the bounce pass through and the end behavior. So factor what, 2x? X squared plus 6? No, I'm doing something weird.
Squared.
Oh yeah, 2x squared, that's my problem. Yeah, you gotta take out the x squared, huh?
Plus
Mhm.
Yeah. So it'll be x plus 3. There we go. Yeah, double check. That'd be 2x cubed. That'd be 6x squared. It's looking good. So there's the right factoring. So now do the quick little graph thing. Find the zeros. Find anything you could plug in for x that would make that 0. Put those dots on the x-axis and decide if they're a bounce or a pass-through, and the end behavior. So this would be x is 0, and this would be x is negative 3. So go to the graph. So 0 and negative 3. Good so far?
When you look for your end behavior, are you looking at the original problem or are you deciding to factor it?
Yeah, either one, Erica, right? Yeah, either one. You could, good question. So for the end behavior, if you multiplied this all out, what would be the front term? Well, if you multiplied right there, it'd be positive 2x cubed, which is the same thing as we had there, huh? Yeah, well, you know what, I'm not answering that very clearly. Yeah, not the one before we had the 0. Yeah, good question. I see what you're saying. It's a good question. Yeah, just any one from the 0 onward. Any of those. Yeah, you want to look, yeah, we're always going from where we had the 0 onward. Good question, yeah. From there forward. So it's positive 2x cubed, so that's up, so it's going up like that. And then we got to decide if it's a bounce or at the x equals 0, at this guy, it's even power, huh? So it's going to bounce, and at this guy, it's 1 power, so it's going to pass through. You okay with that? Right? Because this is even power, so it's going to bounce for the x equals 0. It's going to bounce, and it's going to pass through that guy like that. So there's a rough graph of it. Now, can you answer the final question? What's the final question? Well, greater than 0. Where is it greater than 0?
Negative 3 to 0, and then 0 to infinity.
Yeah. Yeah, everybody see that? That's right. So right here, negative 3 to 0, and then, yeah, so from negative 3 to 0 and 0 to infinity. It's always x-axis. We're given interval, which is always x-axis. So negative 3 to 0, comma, 0 to infinity. We're not including the 0. If they had said greater than or equal, then I would have just said all the way from negative 3 to infinity with a bracket. I would have included the middle. But the height of the function there is right on 0. And they said, no, we only want to know where the whole function is greater than 0. We don't want it equal to 0. So, just like that. Is that okay? Question?
Am I
Barbara,
looking
question?
at my y values?
Yes.
Okay.
The answer is x values. The question is y values. Yeah, so they're saying, because yeah, this is the function here, which is y values. This is the f of x. Yeah, so they're saying, where are the heights greater than 0? That's exactly good question, good comment. They're saying, where are the y values greater than 0? Where is the function above the axis? That's right. Because f of x, the whole function is the y values. They're saying, what x values make the y values above? And we're saying, between negative 3 and 0, those x values make the y values above, and 0 to infinity make the y values above. Exactly. Good. So function values are always heights, y values, on the graph. Race with the clock. Let's see. Okay, let's try that one. X to the 4th greater than a1. So you know what to do, right? Get a 0 and factor. So same first two steps. Get a 0, factor. So factor it as far down as you can. Keep factoring. You can do it 2 steps there, right? So remember how to x squared plus 9x squared minus 9? Remember that kind of thing? And then one more step, right? Go ahead and do one more step. One more factoring step. Okay, do you remember how that other step works? The minus 9 can go, but the other one can't. Do you remember that? Remember, plus has to stay, but the minus can break down further. Do you remember? That's real important. Comes up a lot in calculus. Everybody good with that? Remember how x squared? Because it looks like can't that guy be x plus 3, but it's just not right. Right? Remember that? I'm always showing you that. I'm really hoping that's making sense for you now. It's not. A lot of people think it's x plus 3, but if you check it, you'll see it's not really true. If you FOIL that out, the x squared plus 3x plus 3x plus 9. See how that's actually 6x in the middle? That's not the same as this. It's not true. Everybody see that? So you really need to know it's not x plus 3. It looks so good, but it's just not quite right. So don't let it fool you. So the plus has to stay. But the minus breaks down into plus 3 minus 3. You good to there? Okay, so now go to the graph, right? So step 1 is get a 0. Step 2, it's all factored. Step 3, can you draw a quick little rough graph? And what's the x squared plus 9 part going to do on the graph? Nothing. Remember, there's no x number you could ever plug into that to make him 0, because he's always positive. When you plug in a squared, it's always positive. Add 9, it'll never be 0, huh? So the only zeros are 3 and negative 3. Does that make sense? Only the other 2 parts can make the thing 0. Only 3 and negative 3. Just ignore the x squared plus 9. He can't help. So we go to the graph. So at 3 and at negative 3 are the only zeros. Okay, so now are these bouncers or passers through? Yeah, they're both first power, odd, pass through, odd, pass through. So you're going to pass through both of them. We need the end behavior. What's this thing doing at the end? You just look right here. I mean, there it is, multiplied out. It's positive x to the fourth. If you were to multiply this, indeed, that's what you would get, positive x to the fourth. That's up. These have been all going up in the end, haven't they? So that one goes up at the end, passes through, passes through. It's a big U, really. Some big kind of a U thing. Like that. We good there? Now can you answer the final question? They want to know, where is that thing greater than 0? They mean y values. They're saying, where are the heights? So is that making sense? All of this is the function, is the y, really. Where is y greater than 0? Y is greater than 0 for what x's? That's what they're really asking. So if you're a little person walking back and forth on the x-axis, if you're walking back and forth on the x-axis, where would you see the graph above? That's what they're saying. Where would you see the graph positive? Here and here, huh? And what x regions would that be? Well, that would be on the x-axis from negative infinity to negative 3, and from 3 out to infinity. And no brackets on anything, since all parentheses. So negative infinity to negative 3, comma 3 to infinity. Good on that? Our final answer? Those are the x values where the graph is, where you'd see the graph above the axis. All right, I'll keep moving. You stop me if you have. Okay, so 5x minus 3 over x plus 3 less than 4. Remember the steps. Step 1 is all about get a 0. Step 2, factor. Step 3, graph. Remember that whole thing? So, we have to get a 0 here. Now, it's really tempting to multiply by x plus 3. It's illegal. The math cops will come for you. You can't do that. It looks so good. You say, well, it's great. Just boom, boom, and no more fraction. And if this was an equal sign, that would be totally what we're doing. Yeah, you know what? I should have said that in the beginning. This whole section is greater than, less than. That's the marker of this section. I just assume it because I teach it every year, but let me help you. That's how you'll recognize this stuff in the exam in 2 weeks. When you see the greater than, less than, you go, oh, it's one of those where I got to get the 0 and factor and make the graph thing. That's the unique mark. A lot of people don't notice that, because if that was equals, you would totally just multiply x plus 3 on both sides, right? And a lot of people treat it, watch it, don't write this down, this is all wrong. They kind of, I mean, they have it there, but they don't realize you need to treat it different. They just go, oh, it's just 4x plus 12. They go, oh, that's easy. Just subtract 4x, x minus 3, 12, add the 3. X is less than or equal to 15. It's all garbage. It's all garbage. That's a 0, unfortunately. There's nothing I can do to help that. That's totally wrong. So, but it looks so close to what's right, doesn't it? So I really want to be intentional to help you here. Why the big difference? Why the big difference between equals and greater than, less than? That's the whole section, is greater than, less than, and what a difference that makes. Why? Like, why? What's so illegal about that? I thought we could do the same thing to both sides. Why can't you do the same thing to both sides? Anybody know? I mean, I'd be impressed if you already knew why. Why can't you do that? I don't expect anybody to really know. Let me give you a couple hints, and then it'll come to you. Think about with me for a second. When you have something like, I don't know, negative 2x plus 10 less than or equal to 12 or whatever. Okay, first step, you guys know, subtract 10. Just think with me for a minute. Just watch this. You know, what would you do next to solve for x here? Divide by the negative 2, right? And what?
Flip the sign.
Flip the sign. That's the key. That's the key. You don't know whether to flip the sign or not. Let me show you. You know to flip the sign here because you're dividing by a negative, right? Or if you multiply, what if I have like x over negative 2 less than or equal to 10 or whatever, and I multiply both sides by negative 2, you know, which is, what do I have to do? Flip the sign, right? So you know the rule that when you multiply or divide both sides of a greater than, less than, you must flip the symbol. And if you multiply or divide both sides by a positive thing, you must not flip the symbol. So the point is, when you multiply or divide both sides by a greater than, less than, you need to know the sign of what you're multiplying or dividing by. Because that'll tell you whether to flip or not flip. Well, if you multiply by something having an x in it, it's a variable. You don't know what it is. So you don't know whether to flip the sign or not. That's why that's not allowed. Does that make sense? You can't multiply a greater than, less than by anything having an x, because an x is unknown to you. I don't know what x is. If x happens to be like negative 10, then this is negative 10 plus 3. This is a big negative 7. And I'm multiplying both sides by negative 7. I better flip that symbol. But on the other hand, if this is like 2, then x plus 3, 2 plus 3 is just 5. And I'm just multiplying both sides by 5. And I better not flip the symbol. I don't know. I don't know what x is at this point. So I can't be multiplying both sides by x with a greater than, less than, because I don't know whether to flip the symbol or not. So that's it. That's the reason. So for all of that, you really have to hone in and think a really good, clear thought, and that is, this is a greater than, less than problem. And so for these so you really have to remember, put it on your 3x5 card, for these greater than, less than questions, you can't do what you would like normally do for equals, you know, multiply. Normally, yeah, equals, I would just multiply by the denominator both sides, and away we go. But it's a really, so these steps I'm giving you over here, this is for greater than, less than kind of questions. So you want to put that, you know, on your 3x5 card. There'll be like 2 or 3 of these on the exam that we take in a couple weeks, and you'll reckon these are the only greater than, less than. There'll be nothing else on that exam that's greater than, less than. So when you see the 2 or 3 questions that are greater than, less than, you think, oh, those are the ones where I have to do the 0 factor graph thing, because the normal way just isn't allowed, so I don't know whether to flip the symbol or not. All right. With all that said about what not to do, let's do what's right. Get a 0. So bring the 4 over there, right? So we get 5x minus 3 over x plus 3 minus 4. Got a 0? And now you have to put those guys together. You have to combine them into one fraction. How do you do that? Well, this is over 1. Whenever you have a whole number interacting with a fraction, put it over 1. And then you got to multiply, change the color here, top and bottom by x plus 3, don't I? To get a common denominator there. That good like that? And then where are we at? That gives us 5x minus 3 over x plus 3 minus, and that 4 is going to distribute. In fact, you know what the easiest thing to do is just make it one big bar and distribute the minus 4 right now. Minus 4x minus 12. There we go. Save a step. They both have the same denominator, so you don't need to rewrite it. Is that too fast? Is that okay? See, they're both going to have x plus 3 now. I made both denominators the same, so I can just make them one fraction. But careful, a lot of people get messed up by that sign there. They'll put the minus 4 only on the x, and they'll forget to take it to the 3. And that'll mess everything up. It's a negative 4. That negative is really on that 4 wherever he will go, right? That's his baby. He takes it with him to the x and the 3. So we good to there? Now just combine terms. 5x minus 4x is just x. Minus 3 minus 12 is minus 15 over x plus 3. It's kind of getting scribbly here. We good to there? Now, step 1, get a 0. We got it. Step 2, factor. For vertical, it's the same thing. If we needed to factor anything, we would. It's as factor as it's going to get. Now, we got to find the zeros, don't we? Now it's graph time. It's time to go to the graph. Okay, so let's go to the graph. Where is the thing going to hit 0? Where are the zeros? Zeros are in the top of the fraction. When the bottom is 0? What about when the bottom is? Like, what about negative 3, which makes the bottom 0? What will that be on the graph? It'll be a vertical. It's undefined. It'll be a vertical, won't it? Yeah.
That's the horizontal.
Vertical.
Vertical?
Vertical asymptotes. Yeah. So basically, whatever makes the top 0, because if you make the top of a fraction 0, like 0 over 7 or 0 over anything, it's just 0, huh? If you make the top of the fraction 0, it's just 0. So that'd be 15, right? 15. So way over here at 15, that's just a normal 0. That just makes the whole fraction 0. But if you make the bottom of the fraction 0, which would be negative 3, that's going to be a vertical asymptote, isn't it? So at negative 3, there's going to be a vertical. At positive 15, there's going to be a normal 0. Does everybody see that? It's a little more tricky for the fractions, what they call rational. Rational means ratio, like fancy word for fraction, ratio, one thing over the other. So for the rational functions, the fractions, it's a little more tricky because the top makes zeros, the bottom makes vertical asymptotes. Good there on that? Yeah, Erica?
Why don't we find, like, I thought usually when we have like a fraction, we find our horizontal asymptote.
We can, that we do that sometimes, not required here. And yeah, good question. You might wonder why. We did that before. We did. They specifically asked us, though. We didn't do that like on our own. They specifically said, please find the horizontals, and we did. Why would that not be helpful, though? Because a horizontal is just a place where, like, if it levels up. This one actually does have a horizontal of 1, but that doesn't really matter to me because I only care where it's above this axis and below this axis because I just want to know where it's less than 0. So I don't really care about horizontals in this situation. Good question. Good. All right. So now how do I do the graph? Well, it's a little tricky. Yeah. Yeah. I'm trying to think what would be the easiest thing for y'all to do. Yeah, when you start getting verticals and rationals, I would make a table. The in behavior thing's not as simple because I mean like what is the in behavior? This is kind of weird looking right here. Yeah, I just make a table. Let's just do that real quick. So get rid of this. That's okay. I'll just get rid of this stuff and come up here. And when I say make a table, what I mean is we really have, and also the bounce pass through thing is not as simple. It's just hard. Everything's harder for these rationals. Basically, if you think about it, we have 3 different sections. I need to know what it's doing out here, what it's doing in the middle, and what it's doing over here. When I say what it's doing, I mean I need to know, is it above or is it below? Because that's all I care about. I'm trying to find where it's less than 0, where it's below. So all I don't care which number it's at in particular. I just want to say, hey, are you positive or negative in the right zone? Are you positive or negative in the middle zone? Are you positive or negative in the left zone? That's all I need to know. It can't cross anywhere else. So say it's positive in the middle. Then it's positive everywhere in the middle because it doesn't cross anywhere else or there would be another 0. right? You know what I mean? So I just have 3 sections now. And so let's test them. Yeah, I would just test them. I would just pick like 16 maybe, or 17, 18, whatever. Pick something in the middle, like zeros. Whenever I can choose 0, I go for 0. 0 in the middle, and then like -4, you know. Just pick a number in each of those zones and find out, just plug into the function. So let's do that. Now, and I'll use
the new function.
yeah, the final one, the x minus 15 over x plus 3, you know, less or equal to 0. Yeah, that one, exactly, well said. So I'm gonna plug into that one. I'm gonna do xy, and I'm gonna plug in 16 and 0 and -4 into this, because this is y equals that function right there. So y equals, so for the first one, if I have some room here, y equals, was it 16 minus 15 over 16 plus 3. Hey guys, can I help you to be, because you know you have no calculator on this part, but you can really do it quick and easy without a calculator. If you just remember, it's just a fraction, right? And all I really care is positive or negative. I don't even care what the number is. I just care positive or negative. Well, if you have a fraction, if top and bottom are both positive, it's positive. If just one of them is negative, it's negative. If they're both negative, it's positive. So just look at the signs. It's positive over positive. It's positive. I don't even care what the number is. It's positive, which means it's up here. It's positive in the right section. Does that make sense? So that's why you can do this without a calculator. You know, all you care about is positive or negative. Let's try the middle. Put in 0 now. So it's 0 minus 15 over 0 plus 3. So what is that? Negative over negative, huh? Oh, negative over positive. Be careful. Don't make even one little mistake, and it's going to be all messed up. So be careful and slow. Negative over positive, it's negative, so it's down here. And it must be taking a dive at that vertical, because you never touch a vertical. So it must be like that, huh? It's negative in that whole middle zone. Does that make sense? And then finally, the -4, plug in -4 minus 15 over -4 plus 3. And that's negative over negative. That's positive, huh? Positive. In the middle one was negative. Positive. So that means it's up like here somehow. It never goes below the axis in this section. Everybody see that? Kind of getting scribbly here. Does everybody see that? It's got to be over here. Positive. So in the left section, it's positive. The middle section is negative. The right section is positive. Because I just plugged into the right, middle, left sections. So that's what we do for rationals. Everybody see the difference? Let me go back over here. So, you know, we do the whole end behavior and bounce pass through when it's not a fraction. Right? That's quicker, easier. You can make a table for these too if you want to. If you're just like, I like table making, I'm just going to always make a table. That'll be fine. Just plug something left, middle, right. You'll find the left is positive, the middle is negative, and the right is positive. That'll work fine. If you don't really like the bounce, pass through stuff, just make a table for those too. That'll always be fine. All we care about in the end, remember, is positive or negative, because on step 1 we get a 0. So it's all about greater than 0, less than 0, positive, negative. So coming back to here, so when it's a rational function, when it's a fraction, I've got to make tables, because the bounce pass through thing is not easy to do. So, all right, so what's my final answer then? I want to know, where is it less than or equal to 0? So where is this function less than 0? Right here. It's less than all the way up to the 15. But you can't touch the negative, so it's from -3. If you're a little person walking around back and forth on the x-axis, where would you see it below? From -3 to 15, but not touching the -3, because it's a vertical, parenthesis on the -3, 15 solid bracket, because our original had the equals, right on the 15, less than or equal to 0. There's our answer. Does that make sense on that? That one took a long time. Questions I can answer on that one? Let's see if we can squeeze one more. So on 16, we have 1 over x minus 7 greater than 4 over 9x minus 6. All right, remember step 1, get a 0. Step 2, factor. Step 3, graph. So, got to bring this all the way over, and you get 1 over x minus 7 minus 4 over 9x plus minus 6 greater than 0. Like that. And then you got to combine those together, don't you? Got to combine those together. So that means top and bottom by the common denominator. 9x minus 6, top and bottom of that one, and x minus 7, top and bottom of that one. Is that good? See how it's fine to multiply top and bottom, but I'm not going to do left and right. So if I did left and right, I'd need to know whether to turn that symbol or not, and I don't know. If I have an x, I don't know. So but top and bottom is always okay. Now here's the mistake. This one really gets people. We have just a minute left. Check with me on this. This is, if I was to make a top 10 list of common algebra mistakes, and that would be people through calculus even, this would be probably number 1 on the charts. This minus back here is so far back, and we have so much mess up here that people forget about it in droves. It's the number 1, probably most common mistake. So just move that thing right on that 4. Just move it right there. That way when it comes to the distribution, you won't forget it. Minuses in the middle really go on the thing they're in front of, even for a big old whopping fraction. That minus that was in front of that whole fraction really goes to the top, right? Top or bottom, we just put it on the top of that fraction. And then you distribute 9x minus 6 minus 4x plus 28 over common denominator. See that? And the rest is the same. Combine and go. So let's do this. It looks like we have a little bit more. I was trying to get through it, but I'll put it off one day. We'll fit, but I'm only going to spend like 10 minutes on it probably. Next time it'll be on to 5-1. So they're both going to be due, 4-4 and 5-1. I really encourage you to start on it because they'll both be due on Wednesday. There we go. If you got questions on anything, come on up.